Okay, so now we're going to try question 6, examples 15 and 16. Example 15 is asking, a P wave arrived at the seismic station 3,200 kilometers away at the time 6 hours 10 minutes and 0 seconds. What time did the first S wave arrive at the station? So we in this question know how far the P wave traveled. We know how far away from the earthquake our station is. We know when the P wave arrived at the station. We want to know when the S wave arrives. And to find this out, we just need the time difference between the P and S wave, how long it takes for the P wave to get there versus the S wave to get there, the time difference, and then use that to subtract it from the time the P wave actually arrived to find out when the S wave arrived. So here's how you would do it. Now, in the previous video, part 5, I showed you how to do this with scrap paper by hand. For this video, I'm just going to show it on my screen. If you are unsure on how to do this by the scrap paper by your hand, please refer to the previous video, which is part 5. Okay, so example 15. A P wave arrived at the seismic station 3,200 kilometers away. Okay, here's 3,200 kilometers. I'm going to take my scrap paper and I'm going to align it at 3,200 kilometers to find the time difference between the P and the S wave at 3,200 kilometers. I'm going to align my scrap paper and then I'm going to mark with my pencil where my P wave connects with my scrap paper, and I'm also going to mark with my pencil where my S wave connects with my scrap paper like this. Now, to find the time difference from here to here, I'm just going to take my scrap paper and I'm going to align it with my Y axis, making sure that one of my marks that I made on my scrap paper is connected to my zero or aligned with my zero. And this is showing me that the time difference between the P and S wave when it's 3,200 kilometers away, when my station is 3,200 kilometers away from the earthquake itself, is 4 minutes and 40 seconds. Now I know my time difference. Okay, and I also know that the P wave arrived at the station 6 hours, 10 minutes, and 0 seconds at that time. If I want to know when the S wave arrives, I know that the S wave will arrive later. The S wave is slower than the P wave, right? That's why I'm adding 4 minutes and 40 seconds, the time difference I measured or calculated, and that gives me the answer that the S wave arrived at the stations at 6 hours, 14 minutes, and 40 seconds. So the P wave arrived at this time. The S wave is slower, so the S wave will arrive 4 minutes and 40 seconds later, and we figured that out by measuring the time difference using the scrap paper. Pause this video and try example 16. Okay, so example 16 asks, a P wave arrived at the seismic station 4,000 kilometers away at 1 hour 25 minutes and 0 seconds. What time did the first S wave arrive at this station? Okay, so the S wave must arrive later at the station because it's slower. So I know I'm going to have to add whatever time difference I get to the time that my P wave actually arrived. So my distance is 4,000. I'm going to take my scrap paper and align it with my 4,000 distance right here on my x-axis vertically. And then I'm going to connect or mark a line where my P wave connects with my scrap paper. And I'm also going to mark a line where my S wave connects with my scrap paper. So to find out the time difference from here to here, where my markings, I'm going to take my scrap paper and align it with my y-axis, making sure that one of my lines that I made is aligned with the zero. And this gives me from here to here, I see that my time difference between the P and S wave when it's 4,000 kilometers away, when my station is 4,000 kilometers away from the earthquake, the time difference of arrival of the P and S wave at my station is 5 minutes and 40 seconds. So if my P wave arrived at 1 hour 25 minutes and 0 seconds, then my S wave must have arrived later by 5 minutes and 40 seconds because that's the time difference between the P and S wave at that distance. So that's why I'm taking my P wave arrival time and then I'm adding 5 minutes and 40 seconds, the time difference that I calculated, to find that my S wave actually arrived at 1 hour, 30 minutes, and 40 seconds. It arrived 5 minutes and 40 seconds later. All right, that's it for this video.